In this video, we're going to talk about the electric control system for the motor. When this machine was built in 1978, it was designed to run on three-phase power. Well, I don't have three-phase power. Most hobbyists don't. So we bought a variable frequency drive to convert single-phase service, normal household residential service, to three-phase power through that VFD. And I also put in a low voltage control system that controls the VFD. We'll talk about all that in detail in this video, but first let's just see how the thing operates. This is a 240 volt switch that powers the VFD. And this is the low voltage control panel that controls the output of the VFD. This is the on-off switch. This is a momentary forward and reverse switch. This is a permanent reverse switch, and then forward is down. And then finally, a potentiometer that controls the output of the VFD frequency, which controls the motor speed. And the motor speed controls the speed of the spindle. And then up to the top right is a digital display of the RPMs for the spindle. Here's a view so you can see the spindle and the controls working at the same time. Turn on the power to the VFD and then turn on the motor. You can see the potentiometer changes the spindle speed by changing the motor speed. And the speed of the spindle that is registered on the tachometer. Here I'm just going to throw this thing into reverse, and that VFD just handles those commands, and it's very smooth back and forth. I'll never do this probably when I'm actually running the lathe, but it's just kind of interesting to see how well that VFD responds. Here I'm telling it to go reverse and forward at the same time, and the VFD just stops, which is good. Very nice. Here I'm going to run the spindle on the slowest speed, and then I'm also going to put the engage the back gears. So here we are, the slowest speed on the cone pulley, and then I'm running the motor at 1 cycle per second. So instead of 60 hertz, I'm running it at 1 hertz. I call this the ludicrous slow mode. I'll never use that, but it's kind of cool. I can see how this forward and reverse momentary, that's going to be handy. Before we talk about the details of the control system that I put on the lathe, I want to talk about how it was originally designed to control the three-phase motor. And here it is. This control box was mounted on the back of the lathe, and the pennant switch that controlled the motor was on the top of the lathe, where I have that 220 circuit now. And the controls were pretty simple. Stop, forward, or reverse. And that's all you had. And that's all you really needed. Speed changes all occurred with the changes in the pulley. 4 speeds and back gears. Three-phase power first came in and was attached to these 3 magnetic switches. They're magnetic because if the power went off, it would shut them all off so the machine wouldn't come back on by itself. Or if there was some sort of a malfunction, it would shut them all off. And they would have to be reset with this plunger switch. This is the transformer that powered the low voltage control circuit. The black wires are the high voltage that powers the transformer and the motor. The Red wires are the low voltage control circuit that powered the relays, one bank for forward, another bank for reverse, and the pennant switch controlled those relays. Quite a bit of hardware really to control a single 2 horsepower motor. I will save this with the lathe in case the next guy wants it. Well, I had to make a couple of boxes. I couldn't find the size I wanted, so I brazed together a couple of electrical boxes. I put 8 tabs on for the screws, and I built a little top. And this is going to be the low voltage control box. You've already seen that. And then I also had to make a box for the main power switch. The electrical box I looked at wasn't quite big enough either. They don't look too great on the inside, but they came out okay. This is the 240 volt main power switch. Nothing fancy here. Ground wire is connected to the box. This is the low voltage control box. A lot going on here, but the tachometer readout, the on switch, the forward reverse permanent switch, momentary forward and reverse, and the potentiometer. The LED display and the RPM sensor I ordered off eBay came from China. It took 4 weeks to get here, and when it did, there were no directions. Any kind of symbols on here were all in Chinese, so it did me no value. I had to screw around for probably 2 or 3 hours before I could figure out the wiring configuration. Like I said, kind of ugly on the inside, but it came out okay on the outside. You can see I've got 8 screws for the top here. I did that to just make sure I got a good seal. And also they had to be strategically placed on the top to avoid all the various switches. We also had to put a bracket to install the magnetic pickup. You can see here there's a bracket I put in. I just put a hole through the casting, mounted it there, and then I placed the magnet on the spindle. And you can see I've got tape around it, and I marked it with a Sharpie. So this worked out pretty good too. Here you can see another view, and it does a real good job of picking up the speed, forward, reverse, fast, slow. The pickup registers the speed on the tachometer readout within just a couple of seconds. So it works pretty good. The wiring for the VFD is pretty simple. Here I've got the 240 volt power coming from the switch to the input side of the VFD. You can see here there's 2 legs and the neutral. And then magically it comes out the other side of the VFD 3-phase power. Right there's 3 phases. Then I'm routing it back through the junction box just to make it look tidy, and then back to the 3-phase motor. Now the low voltage control wires you can see right here coming down from the control box, and it's going to be routed to the control panel on the top of the VFD drive. And this is all for low voltage remote controls. And you can see the first 3 wires, this is for 12 volt power, reverse and forward. And these 3 wires are for the potentiometer, 10 volt, variable volt, and 0 volt. I also needed yet another 12 volt power supply to run the tachometer. So I tapped off one leg of the 240 to power this transformer. I put this junction box in just to make the wiring as tidy as I could and protect it from falling chips. And I was able to put this whole thing on a 2x material so that I could move it in and out of the bell on the lathe easily. I think that'll be nice when I need to work on it. Okay, There's only about 3 minutes of this video left, and if you've made it this far, you're going to endure the wiring diagram. The top part of this diagram is the forward and reverse control switches, and there's just 3 of them: on and off switch, forward and reverse switch, and the momentary forward reverse switch. These switches are connected to the low voltage terminal for 12 volt and reverse and forward. The next low voltage circuit is for the potentiometer. You can see it here. It's pretty simple. The 3 legs of the pot are connected to 10 volt, variable volt, and 0 volt. The third low voltage circuit is a separate 12 volt power supply that I had to attach, and it's hooked to the magnetic pickup. Well, it looks like you can't see that real well here. The tachometer has 3 wires coming out, 1, 3, 5, and then the magnetic pickup has a brown, blue, and black wire coming out. And the brown goes to number 1, blue to number 3, black to 5. The 12 volt power supply, positive to the brown and the negative to the blue. The next part of this wiring diagram is for the main power to the VFD, 240 volt from the wall socket to the main switch, and then that transfers power to the VFD, and then there's a 110 that comes up and powers this 12 volt transformer, and then the VFD converts 3-phase power, and that gets sent to the motor. I also need to modify a couple of settings on the VFD drive. This particular unit has 30 separate functions that you can change. It's very flexible, lots of different things. I maybe only understand a third of it, and I only changed 4 from the factory settings. I set the frequency upper limit to 72 and the lower limit to 1, and I set the start and stop control and the frequency control to the terminal instead of the keypad, which is the factory setting. I want to talk a little bit about how the VFD responds to commands from the control panel. Here you can see the power is to the VFD, but the forward reverse is not set yet. So here it is just responding to the potentiometer changing the frequency. The VFD is blinking because it's not forward or reverse yet. Now I click it into forward, and the VFD is going to send the frequency displayed here to the motor. So as the frequency goes up, the motor speed goes up. Frequency goes down, VFD responds, and the motor speed goes down. Here I've got the frequency set to 69.7 hertz, and I'm going to slam it in reverse. And you can see the VFD responds by going down to 0, shutting down the motor, and then going back up to the same frequency in the opposite direction. So you can see how this VFD frequency control is a direct control to that motor. Now here I'm going to do the same thing, it's just at a lower frequency, 23 hertz. As the VFD gets shifted to reverse or forward, it very intentionally powers the motor down to 0, reverses the direction, and then powers it back up again. The momentary switch does the same thing, but since you're controlling that manually, you can just bump it so it doesn't have a chance to get up to the full frequency that it's set to. So by using this switch, you're just able to bump the motor a little bit at a time at your discretion, depending on the need. Now, I am very happy the way this control system worked out and the performance of that variable frequency drive and the way it controls the motor. This is really nice.